going. So, the basics of trigonometry. So first things first, anyway, when we're dealing with the basics of trigonometry, we gotta understand how to convert things from degrees to radians and radians to degrees. So, for example, our first one, convert 225 degrees into radians. Does anyone have any idea how I'm going to convert 225 degrees into radians? No need for the unit circle, no. Just so 225. First of all, anyway, do we know how much 1 degree is in radians? 1 degree is equal to pi over 180. Is that right, radians? Because pi is equal to 180 degrees. We've all done trig in school, it's usually second or third topic you do in fifth year. So, good bit of revision in this. So, pi is equal to 180 degrees. 1 degree is equal to pi over 180 radians. So, if we're converting 225 degrees into radians, we say 225 degrees multiplied by pi over 180. Girls, you hardly have 2 logbooks there by any chance, see? I left my one in Kilkenny. Can I borrow one in each share? Sorry. So, while we're doing this, and all of today, we are going to be looking at page 13. Alright, page 13, the logbook has the majority of the information we need. So, what is 225 pi multiplied by pi over 180? Sorry? Yeah, into the calculator, and what do we get? Fire it straight into our calculator, and we should be getting 5 pi over 4. Is that okay? Do we all know where pi is on our calculator? Anyone not? Okay, right, good stuff. Just make sure. Example number 2, right. I'll do this one in your own. Convert 240 degrees into rads. And that's 240 degrees multiplied by pi over 180, which is equal to 4 pi over 3. Right, last one, have a go at this one. Convert 450 degrees into rads. And we get 5 pi over 2. 450 degrees divided multiplied by pi over 180 equals 5 pi over 2. Right. We also got to be able to go the other way. So, example 4. Converting 5 pi over 3 rads into degrees. Very easy in this one. What did I tell you pi is? Begin? How many degrees? 180, exactly. So for this one, 5 times 180 over 3, because pi is 180. So that's 5 times 180 over 3, and we get that is 300 degrees. Off you go and convert 11 pi over 6 into degrees for me, please. We get 330 degrees. 11 times 180 over 6 equals 330 degrees. Right, stepping it up. So, as I said, we're going to fly through the basics on this first of all. Evaluate them. So now that we know how to get values, we have to be able to evaluate them. So, evaluate cos squared 45 degrees plus the sine of 30 degrees. Just calculate our work. Just make sure we know how to do it. What's another way of saying cos squared 45 degrees? What's the rules with trig there? What can we do to the cos squared 45 to make it easier to work with? The cos squared theta is equal to cos of theta to be squared. You can move it to the outside. Is that alright? Theta is just any angle. It's just it's like a symbol used in trigonometry for a reference angle. Did you forget your calculator? Oh, here. I got a second. Did you use that one or the sharp one? Oh, well. No, when you start in degrees, leave it in degrees. So that is the cos of 45 to be squared plus the sine of 30 degrees. Cos of 45 degrees is 1 over root 2 to be squared plus the sine of 30 degrees is a half. 1 over root 2 to be squared is a half plus a half, which is 1. You happy there? Right, one more of those. Have a go at this one. Evaluate sine squared of 30 degrees plus tan squared of 45 degrees. Off you go. Often it's easier to use the angles from the logbook than the angles they give in your calculator. Like, I don't know why it is, but with certain calculators, if you put things like, for example, the cos 45, if you put cos 45 into your calculator, you get root 2 over 2, is it? Yeah, it's way easier to manipulate. Another way of saying that is 1 over root 2. I don't know why it comes out in that form, but these two are the exact same thing. It's often easier to use the angles, the reference angles from your logbook than the ones off your calculator. We're trying to manipulate. Right, we get an answer? What we get? 5 over 4. So that's the sine of 30 to be squared plus the tan of 45 to be squared. Sine of 30 to be squared, sine 30 is, sine of 30 to be squared is a half to be squared plus the tan of 45 to be squared is 1 to be squared. So a half squared is 1 over 4 plus 1, which is 5 over 4. Right, same thing with rads. Have a go at this with me. Evaluate the sine of pi over 4 by the cos of pi over 4 minus the sine of pi over 6. If you're putting that into them figures into calculator, you must change it to rads. Anytime you start seeing like pi over 4 and cos and sine of pi over 6, you must change your calculator to rad mode. Anyone who doesn't know to that, give me a little shout. Right, so the sine of pi over 4. Pi over 4 is 45 degrees, so it's 1 over root 2. Multiplied by the cos of pi over 4. Sorry, pi over 4 is not sine of pi over 4 is, 1 over root 2. The cos of pi over 4 is by 1 over root 2. Minus the sine of pi over 6, which is a half. So 1 over root 2 multiplied by 1 over root 2 is a half, isn't it? Minus a half, which is 0. You happy with that? Right, so step it up a bit again. We're nearly on the unit circle. So before we get to the unit circle, we have to understand when the degrees between 0 and 90, and then we'll get to the degrees between 0 and 360. So, if the sine of theta is equal to 1/3, where theta is an angle between 0 degrees and 90 degrees, I want you to find, first of all, cos theta, and then find tan theta, and then hence prove cos square theta plus sine square theta equals 1. So the sine of theta is equal to 1 over 3, where 0 degrees is less than, where theta is greater than 0 degrees and less than 90 degrees. Find the cos of theta and the tan of theta, and hence prove that cos square theta plus sine square theta is equal to 1. First things first, when you see between 0 degrees and 90 degrees, what shape should we be thinking? Triangle, come on. What type of triangle? When you see between 0 and 360, it's the circle. When you see between 0 and 90, it's the right angle triangle. Is that okay? So, theta is 90 degrees, less than 90 degrees, and greater than 0 degrees, so we're thinking right angle triangle. Is that okay? So first thing we do is we draw a right angle triangle. Next thing, right, we all learn this a bit of a different way. When we're dealing with right angle triangles, what's this poem that helps us? You use soccer elements. Silly old Harry? Yeah. Silly old Harry, caught a herring, trawling off America. Alright, silly old Harry, caught a herring, trawling off America, or soft cat toga, whichever way you're called, depending on your creature. So, S stands for O, opposite, hypotenuse, adjacent, hypotenuse, and opposite, adjacent. So, there's my angle. There is my angle. Let's label this together before we start. What's that? Hypotenuse, this. Opposite of this down here. Adjacent. Alright, that's just doing a circle division there. That's your angle. I shouldn't have little line going through it. That should be an opposite. That's your opposite, hypotenuse, and that's your adjacent. So, we know the sine of theta is equal to 1 over 3. So, if the sine of theta is equal to 1 over 3, what's 1? Opposite, what's 3? Hypotenuse. Alright, off we go and see if you can solve it from there. Just got to label the sides of the triangle right. How do we find the third side? Pythagoras theorem, exactly. So once you have your three sides in, you get cos adjacent over hypotenuse, tan opposite over adjacent, and then I want you to show me how cos squared theta plus sine squared theta can give me 1. No, you don't have to actually figure out what theta is. You just have to say tan of theta is equal to, for example, 3 over root 2, or you can leave it as a fraction. Keep it correct. Yeah, no, leave it sorry in degrees. No, leave it in degrees. Leave it sorry in degrees. It's only when you start seeing pies that's red. Alright, let's have a little look at it. So, first things first, draw our triangle. Terrible right angle triangle. There's your theta. Sine, opposite, silly old Harry, opposite over hypotenuse. So opposite is 1, hypotenuse is 3. 3 to be squared equals 1 to be squared plus a squared for adjacent. 9 is equal to 1 plus a squared. 9 minus 1 is 8 is equal to a squared. Square root of 8 is equal to a squared. Square root of 8, or you can break it down into 2 root 2 is equal to a. So that's 2 root 2. Right, we then had to find the tan of theta, trotting off America, opposite over adjacent. Opposite is 1 over adjacent, which is 2 root 2 or root 8, whichever way you want to leave it. The cos of theta, cos a herring, a over h. Adjacent is 2 root 2 over hypotenuse, which is 3. We all happy there? Right. The next bit of the question then asked us the cos squared theta plus sine squared theta is equal to 1. So that's the cos of theta to be squared plus the sine of theta to be squared is equal to 1. The cos of theta is equal to 2 root 2 over 3 to be squared, plus the sine of theta is 1 over 3 to be squared. 2 root 2 over 3 to be squared, that's the square root of 8. Square the square root of 8, you get 8. Square 3, you get 9. 8 over 9. Plus square a third, you get 1 over 9. 8 over 9 plus 1 over 9 does give you 1. Therefore, true. Were you getting that right when you're throwing into your calculator, or was it coming up a bit awkward? Yeah. Are we all happy getting that? Right, we're going to do another one of those, is that right? This time. What's this? Example 10. Example 11. The tan of A is equal to 2 over 3. where A is an angle less than 90 degrees and greater than 0 degrees. So I find sine A and cos A in third form. I show that cos A plus sine A is greater than tan A, and B cos squared A plus sine squared A is equal to 1. And find the angle of A. Last one. This, usually the unit circle comes up, but this has actually come up 2 or 3 times on leaving cert papers since the new course came in. So, what new course came in I did my leaving cert 2012, I think. Yeah, 2012. So, since the new course came in 2012, this has come up twice. is show cos A plus sin A is greater than tan A. You can break that one into that decimal if you want to make it easier. Show it's easier. You know, a minute there, guys, for a run through that. Right. Let's have a quick look at it. So, before we jump into the unit circle. So, first things first, then we draw our triangle. There's our angle. The tan of, or you better use A instead of theta, confuse things. Tan of A is equal to 2 over 3, trawling off America. Opposite is 2, America, adjacent is 3. So, the sine of A, silly old Harry, opposite over hypotenuse is, we got to get the other angle first of all. 2 squared plus 3 squared equals h squared, the hypotenuse. 13 is equal to h squared. Root 13 equal to h. So, silly old Harry, opposite is 2 over root 13. The cos of A is cot A herring. Adjacent is 3 over herring, 3 over root 13. Right. I then. Show that cos A plus sin A is greater than tan A. So the cos of A, which is 2 over root 13. No, it's not, Paddy. That's the sine of A. 3 over root 13, the cos of A, plus the sine of A. Sine of A is plus 2 over root 13, is greater than tan A, which was 2 over 3. So 3 over square root 13 plus 2 over 3 over root 13 plus 2 over root 13 is 5 over 1.38 greater than 2 over 3, which is 0.666 dot 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 dot, which is true. They also wanted to show that cos squared a plus sine squared a is 1. So that's cos squared a plus sine squared a is equal to 1. That is the cos of a. The cos of a is 3 over root 13 to be squared, plus sine squared a is 2 over root 13 to be squared. And that's equal to 1. That is 9 over 13 plus 4 over 13 is equal to 1. 9 and 4 is 13 over 13 is equal to 1, therefore true. And the last one is find the value of a. If they say find the value of a, just to make sure that if you got one of those wrong above, always use the angle that they give you in the question to find it. Because if you made a mistake in one of these, you're going to make a mistake here. They won't penalise you twice, so try not to get penalised twice. So the tan of a, obviously this is a handy enough question, but on the harder ones it's very important that you always try to use the figures that they give you, not the one you use yourself. 2 over 3. A is equal to, how do we get the value of that? Tan inverse, exactly. Tan inverse of 2 over 3. Shift tan inverse of 2 over 33.69. Anytime you move tan over, you get tan inverse. Right. Z unit circle. So, example number 12. Once again, depending on which teacher you have, I learn as C, A, S, T, or all silly tomcats. I think some people do it that way. I'm not too sure. I learn as cast anyway, C, A, S, and T. I think some people learn as all silly tomcats. What this means is any one of your 3 trigs are positive here. So sine, cos, and tan, because all are positive. Only sine is positive, only tan is positive, and only cos is positive. So what I mean by this is, you have the cos of 210 degrees. Is that right? So first things first, you always work off the x-axis line. So we're working off this one. Now, 210 degrees is you always start here, anti-clockwise. So you go around the clock, out about, we'll say, roughly there. That is 210 degrees. Is that okay? That right there is your 210 degrees. But we're always working off the, we'll say, the 0 to 180 line. That means we only want to find this reference angle inside here, which is how much? 30 degrees. Is that okay? So that means cos in there. Is that cos going to be negative or is that going to be positive in there? It's going to be negative. How would we know it's going to be negative? What's the only thing that's positive inside there? Tan, exactly. So it's going to be minus the cos of what's our reference angle? Someone say it? 30 degrees. Do we all know where I got 30 degrees from? As in, that's 180, and from 180 to 210 is 30. Alright, so that's the cos of 30 degrees. So minus the cos of 30 degrees. Go to our log tables. Look at 30 degrees. What is 30 degrees? So that's minus root 3 over 2. Okay? As I said, try use the log tables more than the calculator because it just gives you better reference angles to work with. And you can see your little unit circles up there on the top of page 13, right in the middle of the page. Right, have a go at this with me. Example number 13. Write down the exact value of the following. Write down the exact value of the sine of 150 degrees. Obviously, we can do a lot of these in our calculator, but it's important we know the process because in a minute we're going to have to work backwards. We're going to be given, for example, this and told it's either cos, sine, or tan, and we're going to have to figure out what that is. Alright, we're going to have to work backwards in a moment, so it's important we know the process going forward so we can work backwards. Does that make sense? Right, the sine of 150 then, so draw your little unit circle again. C, A, S, and T. We have the sine of 150 degrees. So working off our line again, we go over as far as about here, and that is 150 degrees, yeah? Up, down, what's that in there going to be? 30 degrees, exactly. So, that then is the sine of 30 degrees. Positive or negative? Positive because it's sine. The sine of 30 degrees is equal to a half. Right, one more of those. Find for me the tan of 330 degrees. Off you go. Right, let's look at it. So, this time we are looking for the tan at 330. C-A-S-T. We go the whole way around to here. It's 330. Get our reference angle. We always go off our x-axis line, which is 30 degrees. Right. Positive or negative? Minus the tan of 30 degrees. Tan of 30 is minus 1 over root 3. Right. Do it in red, so get for me the sine of 7 pi over 6. Off you go. Same thing, get me the exact value. So what I'd recommend is converting rads to degrees and then working off that. All right. So like I showed you at the very beginning of the class, convert the rads into degrees. Right, let's have a little look at it. That is the sine of 7 times 180 over 6. So that is 7 times 180 over 6. Sine of 210 degrees. Unit circle. C-A-S-T. Start from here, go the whole way around to 210. Draw your reference angle. 180, that means this is 30 degrees. Positive or negative? The negative sine of 30 degrees, which is 30 is a half. Minus a half is your answer. You happy? Right. Something a bit different. Small but different. Before we move on to the unit circle equations. The sine of negative 210 degrees. Right. Very important. In our logo. Right corner. Cos of minus a is equal to the cos of a. Sine of Cos is a lovely one, nothing changes. Cos of a negative angle is the cos of a positive angle. Sine of a negative angle though, and tan of a negative angle, you must go the other way around the user. You must go clockwise. So what I mean by that is, for the sine of minus 210, that is equal to minus the sine of 210. Is that alright? With that then, we say, our unit circle here, C, A, S, T, 210 degrees this way. Because it's a negative angle. Up to here, out to here, it's 30 degrees. Now, is sine positive or negative in that quadrant? Positive. So that is the sine of 30 degrees, which is a half. Negative angle, we must go the other way. Is that right? Right, I want you to go one of these. The tan of minus 60 degrees. Let's jump to the jets. Right, let's look at it. Don't worry guys, only half an hour left. So once again, tan of minus 60. Tan of a negative angle is a minus tan or plus tan? Looking at the board on the left, minus. So it's minus the tan of 60 degrees, so it's a negative angle. C, A, S, T, starting here, out you go, 60 degrees. So that's minus the tan of, what's 60 degrees? 60 degrees is root 3. So that's minus root 3. Sorry. Minus root 3 is our answer. And we know it's negative because it's in cos. Right. Unit circle equations. Let's look at them. Do them in degrees, we look them in rads. Solve the equation. The sine of theta is equal to 1 over root 2. So, as I said, we're working backwards now from what we've just been doing. Draw a little unit circle over here, we're going to need it in a minute. C, A, S, and T. Right, first things first, what do we got to do? Find the angle, exactly. So out here, theta is equal to what? Sine inverse of 1 over root 2. What's sine inverse of 1 over root 2? Yeah, 1 over root 2, yeah, it's 45 degrees. Right. Is it positive or negative? What are we dealing with here? Sine, positive or negative? Positive. So which quadrants is it going to be in? First? 2. Sine is positive in all, and sine is positive, obviously, in sine. So we got to get our 2 angles then out of that. In here, what's our angle going to be? .45 degrees. And then we also have a second one. What's it going to be? .45 off this, which is 135, exactly. Therefore, the sine of theta is equal to 1 over root 2. Theta is equal to 45 degrees or 135 degrees. There are your 2 answers. If I ask you to give the general solution on that then? Any idea on the general solution? That's if you find all 4 quadrants. So it'll be 45 degrees is equal to plus n times 360 degrees or 135 degrees plus n times 360 degrees. And then we say n is equal to 0, n is equal to 1, 2, and 3. We'll be doing a few of those in a minute. We'll focus on getting these right first of all. Is that right? So example number 19 then. I want you to go ahead and do this one yourselves. Solve the equation. The cos of theta is equal to root 3 over 2. Right, we have a little look at it. So, our unit circle, C, A, S, T, theta is equal to the cos inverse of root 3 over 2. Theta is equal to 30 degrees. So, positive A and C, 30 degrees, and off here, the whole way around makes that 330 degrees. So, theta is equal to 30 degrees or 330 degrees. Right, have a go at this one when it's in rads. Cos of theta is equal to minus root 3 over 2, where theta is in radians between 0 and 360. Sorry, 2 pi. We're dealing with radians. So I want you to get it for me in radians. So very much the same, you get our answer and then just throw it into radians. Is that alright? Minutes left, please. Remember now, it's a negative limit. So now our cos is positive, our cos is negative. Very important. Now our cos is positive, our cos is negative. Let's put 150 into the rads. sec, please. Right, let's have a little look at it. So, our unit circle. C A S T. Our reference angle is theta is equal to the cos inverse of minus root 3 over 2, which is minus the cos inverse of root 3 over 2, which is minus 30 degrees. So wherever cos is, negative, isn't it? Minus cos. So this is your 180 line. Cos is negative in sine and in tan. Out here, that's 30 degrees. 30 from 180 is 150 degrees. That's your 30 degrees. 180 plus 30 is 210 degrees. So theta is equal to 150 degrees or 210 degrees in rads. 150 multiplied by shift pi over 180, 5 pi over 6, or 210 multiplied by pi over 180, 7 pi over 6. We happy with those? Right, have a go at this one for me then. Example 21, geez, we're flying through. Do for me, just before we move on to double and triple angles, the sine of theta, one more of these, is equal to minus 1 over root 2, where theta is in rads, between 0 and 360, 0 and 2 pi. So, this, or the 90 degree one, come up every year. So this one, if you take from 2010, we're now 2019, 9 years. I think the 90 degree one's come up twice, the other 7 has been a form of this one or the general solution, what we're going to look at next. So this is nearly a banker to come up over the next 2 years. Obviously next year's the one that matters the E, but hopefully next year's the only one that matters the E. It is a good one to get your head around, this one or the general solution. It's going to be probably one or the other, or the 90 degree one that we did today is going to come up. Is that alright? And you'll see that as we go through the papers when we get to the trig. 15 minutes, please. Right. So, C, A, S, and T. Theta is equal to the sine inverse of negative 1 over root 2. So theta is equal to the negative sine inverse of 1 over root 2. So it's a negative angle. Theta is equal to 1 over root 2 for sine is 45 degrees. So our angle is a negative 45 degrees. So where is sine negative? T and C. So 180 plus or 45 degrees. And you're going to take away 45 degrees over here. So 180 plus 45 is 225. Theta is equal to 225 degrees, or 360 minus 45 is 315. So in rads, 5 pi over 4, or 7 pi over 4. Is that okay? Right, general solution. So the general solution for rads is plus 2n pi. General solution for degrees is plus n times 360 degrees, because 2 pi is 360 as well. So we're going to turn, we're going to get a treble angle and a general solution, and we're going to do it all in one question, all right? We'll probably get 2 of these done, and then we're out the gap, guys. Enjoy your weekend. So, example number 22. Solve the equation. The cost of 3 theta is equal to a half. Normally, where theta is just an element of r. And then, for the general solution, where theta is less than or equal to, greater than or equal to 0 and less than or equal to 2 pi in rads. Right, first things first, draw our unit circle. C, A, S, t, where the cos of 3 theta is equal to a half. 3 theta is equal to the cos inverse of a half. So 3 theta is equal to cos inverse of a half, 60 degrees. Is that okay? So let's get the reference for 3 theta. So some teachers do this differently. Some teachers go away and get theta is equal to 20 degrees, and then if to break down the thing later on, I'm going to get it for 3 theta. I'm going to show you this way. So you might have been shown a slightly different way. It's not much of a difference. Is that alright? So cos A, S, and T. Is it positive or negative? Positive, exactly. It's a half. No negative in front of the reference angle. So we have 60 degrees and we have 60 degrees. So therefore, theta is equal to 60 degrees, or 60 away from 360? 300 degrees, exactly. So theta in rads is equal to 60 multiplied by pi over 180, pi over 3, or 300 multiplied by pi over 180, 5 pi over 3. Therefore, our general form, just so you know, lads, that is the first bit there, where you just have to find theta as a real number. Alright? When you see this, like I didn't do it on the rest of the last couple of questions, because I just kind of want you to get it right. But when you see this, they're asking for it in general form. So just throw it into general form. If you put it into general form and you're saving yourself just losing a few marks just at the end. If they ask for this, they just want it as an angle. If they put it up like this, they want it in general form. Is that alright? So, or in general form. So we know that 3 theta is equal to pi over 3 plus 2n pi, or 3 theta is equal to 5 pi over 3 plus 2n pi. So we're not looking obviously for 3 theta, we're looking for theta. So we divide by 3. Theta is equal to, divide pi over 3 by 3, we get pi over 9 plus 2n pi over 3. Or pi is equal to 5 pi divided by 3 is 5 pi over 9 plus 2n pi over 3. And then you start off, leave n equal to 0, n equal to 1, and n equal to 2. So we try out n equals to 0 is pi over 9 plus 2 times 0 pi over 3. So you literally put that into your calculator. Shift pi over 9 plus 2 times 0 shift pi over 3. Now, very important, don't delete this after you get the answer, because you're just going to change the 0 to 1, the 0 to 2, and then the 0 to 3. It makes life a lot easier. So that's equal to pi over 9. Leave n equal to 1. Pi over 9 plus 2 times 1 times pi over 3 is, just go back up and change the pi to 1. 7 pi over 9. N equal to 2. Pi over 9 plus 2 times 2 pi over 3 is equal to 13 pi over 9. Now try n is equal to 3. Pi over 9 plus 2 times 3 pi over 3. We get 19 pi over 9. Why do I reject that answer? Why can't I accept that? Exactly, good man. What was the original statement? It must be between 0 and 2 pi. How many times does 9 go into 19? 2 point something, because 9 over 18 pi over 9 wouldn't work, because 9 goes into 18 twice. Does that make sense? So we reject this answer and you just rub it out. No need for it. And then you go back and do the exact same thing for 5 pi over 9 plus 2n pi over 3. So you go 5 pi over 9 plus 2 times 0 pi over 3. You get 5 pi over 9. Five pi over 9 plus 2 times 1 pi over 3, which is 11 pi over 9. And the last one, 5 pi over 9 plus 2 times 2 pi over 3, 17 pi over 9. And there's no need to check 3 there, obviously, because that's going to blow it up above it. So then your answers are pi over 9, 7 pi over 9, 13 pi over 9, 5 pi over 9, 11 pi over 9, and 17 pi over 9. And that, along with the other ones, is basically any one of the 3 that we've done today. The right angle triangle, the first type we did where they gave you the degrees and you have to work the reference angle, or if this one comes up, it's 15 marks, and it's actually grand because it's the exact same as the other 2, just in reverse. Is that okay? We're going to be jumping into 3D problems the next time. So sine rule, cosine rule, and how they come up. So sine rule and cosine rule is guaranteed 100%, nail it on, going to come up, paper 2, question 7, 8 or 9, they're going to give you a 3D problem and they're going to get you to work something out. So this is going to come up in a short question. Generally paper 2 question, I think it's 3 or 4. It's a trig question, it's going to be one of the 3 of those. Is that okay? Right guys, good work, enjoy yourselves. Also, I forgot to say to you last week that because study goes on till 12:30, you can take a 10-minute break now and jump in there if you want to bring homework with you to finish off over the weekend. It's open to you, it's free to you because you're paying for this. Is that alright? So it's open to you next week if you want to take a 10-minute break, get a bit of homework done to get all the weekend off. I'll leave it up to you in future. Is that alright? It runs on until